Hello everyone and welcome to this Probability and Statistics for Business 1 course. Today we will be going through a very brief introduction to this course, why you are learning statistics and how it's applied in business statistics. And then we'll be also looking at a few terminologies, and that will be the end of this particular chapter. So the learning objectives for this particular chapter would be how businesses use statistics, the basic vocabulary of statistics, types of variables, levels of measurement, and the most important question, why learn statistics? So we will first look at why we learn statistics. Now, it's important to keep in mind that statistics is a branch of mathematics. So it is very important that you have a very firm grip on your basic mathematical knowledge. Foundations of mathematics is very important in order to have a better understanding of statistics. Statistics gives you a very good idea about how to take business decisions, and it also gives you a certain sense of everyday life. So, like I said, it makes better sense of the world and makes better business decisions. Why we learn statistics, I have given a detailed explanation to this in the introductory video of this particular course. So I would kindly ask you to go to that video and check that particular video out. In this particular introduction chapter, I will be looking and focusing upon 4 areas. One area is statistics in business. The other one is basic vocabulary of statistics, identifying types of variables, and levels of measurement. First, let's take a look at statistics in business. So, business statistics is used in making decisions. That's the most important thing to keep in mind for a business or company, because these decisions have a certain particular uncertainty incorporated to it. Now, in business, statistics has many important uses. For example, you collect data and you summarize this data. Then you draw conclusions about this business data. Then through those conclusions, you derive forecasts for the business. And through that forecast, you try and improve the business process. For example, take data pertaining to a apparel industry, right? So a particular business in the apparel industry has particular data. So they collect the data and they summarize it. And based on the data, they draw conclusions. Okay, is my business profitable within this year? Or how are the expenses like compared to last year? Then you make reliable forecasts. You check that particular business checks, okay, what would be the profitability for next year? What may be the expenses for that particular business in the next 5 years? Likewise. So you make those forecasts, and then since you have a basic understanding about what it has been like and what it might be like, you try and improve the business process accordingly. Now, in statistics, there are 2 main branches that you have to keep in mind. One is descriptive statistics. The other one is inferential statistics. Descriptive statistics is very easy. It's where you collect, summarize, then you analyze, and then present your data. Inferential statistics goes a little bit beyond that, where you collect data from a small group in order to draw certain conclusions about a larger group. Now, like I said, descriptive statistics, you collect data. For example, through a survey, a market survey would collect data. Then you present the data. You present it using tables, graphs, and then finally you can characterize data. For example, you have the sample mean, median, mode, right? So that is descriptive statistics. Then you have inferential statistics. You try and estimate, for example, you try and estimate the population mean weight using sample mean weight, right? Or for example, think of an example like this. So you're trying to figure out what is the female representation in the corporate sector in Sri Lanka. So you carry out a market survey and you gather data. But you gather data not from all the corporates, because that would be impractical. Therefore, you look at certain big corporates, you gather data from those big corporates, and then analyzing that data, you come to a conclusion, and then you try and make certain inferences about the whole country, right? So you draw data from a sample and you infer about the population. And then you come to a conclusion saying, okay, 60% of, there's a 60% of female participation in corporates in Sri Lanka, something like that. And then you have something called hypothesis testing. This hypothesis testing will be a very important component that you will have to look at. We will be taking this subject later on in this course. Right, that's statistics in business. Then let's look at a few terms that you have to keep in mind, right? So, for example, we have a term called variables. What are variables? Very simple. It's a characteristic of an item or an individual. Now take a company. Sales, expenses by year, net profit, all of these are variables. Data, then you have something called data. Data are the values associated to those variables. So for example, take sales. Sales in 2015, say it's $25,000. So that's data, the value associated with the variable. Then you have another terminology called operational definitions. Now this is very important. Operational definitions mean universally accepted meanings that are clear to all associated with an analysis. Now, if I take, for example, the variable sales per year. Now, someone can say, are you talking about sales per year per store? And another person can say, are you talking about sales per year for the entire chain of stores? So you see, there's a mismatch, or there's a miscommunication. So it has to be properly defined. What do you mean by sales per year? It should be either sales per year per store, or it should be sales per year for the entire chain of stores. It has to be properly defined. That is what this operational definitions is talking about. Then we have something called population. Population is very simple. It's all the items or individuals about which you want to draw a conclusion. The key term is all. You want to draw a conclusion of all the items that you want to draw a conclusion about. For example, say like the example that I took, the female representation in the corporate sector in Sri Lanka. So your population would be Sri Lanka, right? But a sample is a portion of the population. So you are taking, okay, you can't actually practically look at the female representation in corporates within Sri Lanka. So you take some of the big corporates and then you analyze that data. So that you take only a portion. That is why you call it a sample. A parameter is a numerical measure that describes a characteristic of a population. For example, you can take Food City, for example. So you can have average amount spent by all customers who shopped at Food City this weekend. That would be a parameter. Average amount spent by all customers who shopped at Food City this weekend. Now, a statistic would be, it says, is a numerical measure that describes a characteristic of a sample. A statistic would be the average amount spent by 30 customers who completed a customer satisfaction survey. Parameter would be average amount spent by all customers. A statistic would be average amount spent by 30 customers who completed the survey. So you see, that's the difference between a parameter and a statistic. Parameter is a numerical measure that describes a population. Statistic is a numerical measure that describes a sample. So you take a population and there are specific parameters that describes this population, and from that population you derive a sample, and there are certain measures to describe called statistics for sample. So we now looked at statistics in business, right? And then we looked at basic vocabulary of statistics. And now let's try and identify types of variables. So we looked at the definition of a variable. Now we are trying to look at what are the different types of variables. So you have two main types of variables. You have categorical variables and you have something called numerical variables. Categorical variables are qualitative. That is, it is a variable where the answer is such that it's a yes or no, something like that. There are no numbers defined to it. In a numerical variable, it's quantitative. And there are two types of numerical variables. One, it could be discrete. The other one, it could be continuous. Discrete arises from a counting process. For example, 1, 2, 3, likewise, discrete. Continuous is a measuring process. The best example for continuous variables would be consider time, right? It's a continuous variable. So this is a small illustration of the two types of variables. You have categorical and numerical. Categorical, you have examples like the marital status, political party, eye color. So all qualitative. Numerical variables, there are two types, discrete or continuous. Discrete could be number of children. So you count, right? There can't be 1.5 children. There's either 1, 2, 3, likewise. Or you have defects per hour. Then you have continuous variables. For example, weight, voltage, time. Those are all continuous numerical variables. So those are types of variables. Then we have levels of measurement. What is this? The values of variables can themselves be classified by the level of measurement or measurement scale. Statisticians use the terms nominal scale and ordinal scale to describe the values of categorical variables. And they use interval scale and ratio scale to describe the numerical variables, right? So, like we said before, statisticians use nominal scale and ordinal scale to describe values for categorical variables. So let's look at that first. So take a nominal scale. What does that do? It classifies the data into categories. But the important thing is no ranking is implied. Right? So there's no particular ranking. So for example, take, do you own a personal computer? The answer would be yes or no. Those are the categories. Then types of stocks owned. So you can have growth stocks, value stocks, or bonds, or whatever. There's no ranking. Then you can have, what is your internet provider, right? There's no ranking there as well in the answer. These answers are your categories. So that's why you call these as nominal scale, right? In the other case, in the ordinal case, it classifies your data into distinct categories where there is a ranking. In the nominal scale, if the data was classified where there was no ranking, in the ordinal scale, there is a ranking. So, for example, a categorical variable take student class designation. So what are the categories? Freshman, sophomore, junior, senior. There's a rank. Freshman is the first year, sophomore is your second year, junior is your third year, senior is your final year. So there's a particular rank to it. The best example would be these bond ratings, right? So Standard & Poor and other companies issue these bond ratings. For example, AAA, AA, A, BBB. So BBB bonds are more riskier than AAA bonds. AAA bonds are much more safer. So there's a particular ranking to it. Now, we were talking about categorical variables. Now, if you talk about numerical variables, the levels of measurement would be interval scale and ratio scale. Interval scale is an ordered scale in which the difference between measurements is meaningful quantity, but the measurements do not have a true 0 point. Okay. Then the ratio scale says is an ordered scale in which the difference between the measurements is a meaningful quantity, same thing as before. And the measurements have a true 0 point. So the difference between this interval scale and the ratio scale is interval scale does not have this thing called a true 0 point. Ratio scale has this particular true 0 point. And this is something important. You will have to search on this what this true 0 point means. But if I were to give you a brief introduction, a true 0 point is a point where nothing of the variable exists. So if you take, for example, money, right? If you say 0 amount of money, that literally means that you do not have money. But if you take temperature and if you measure it in Celsius, say you have 0 Celsius, does that mean that there's no temperature? That's a question, because does 0 Celsius mean the same thing as 0 Fahrenheit? Not really, right? So that's why we consider temperature on the interval scale. And on the ratio scale, we have all the other numerical variables. So I have noted a few examples here. Temperature, SAT scores, they're all interval scale. Why is that? They don't have a true 0 point. But if you take height, weight, age, salary, all of these have a true 0 point, right? If you say 0 centimeters in height, and if you say 0 meters or inches or whatever it means the same thing. There is no height in existence. Same with weight. If you say 0 kilograms or 0 grams or whatever, it means a weight does not exist. And then there's one other point that I couldn't make, that is in the case of age. Now, age can be either a numerical variable or a categorical variable. Why is this? Now, when you say age, you might suddenly think, okay, it's a numerical variable. Why? It deals with numbers. But consider this particular example. Now, if you're comparing buying habits between children, adults, and retired people, you're considering age, but is it actually a numerical variable in that sense? Because you're comparing buying habits between these different age groups. In that sense, in that particular example, it would be better to categorize age as a categorical variable. So that is why I said these operational definitions. We talked about a particular terminology called operational definitions. It's very important to clearly define what your variable is, right? That is how you decide whether it's a numerical variable or a categorical variable. So those are the 4 sections that I wanted to talk about in this particular chapter. And here I have given a small summary of what we were talking about. The objective of this particular chapter was to introduce to you certain terminologies that are very important, because these terminologies will be used in later chapters and you have to have a firm grasp of these terms. And then I would also recommend that you use this particular reference book, right? Basic Business Statistics, Concepts and Applications by these 3 authors. It's a very easy book to read and it's easily understandable. Please refer to this book. And that is it. Thank you very much, and hope you have a productive day.